Hello students, today let's learn Introduction of Set. In mathematics, a collection of objects is called a set. Consider the following examples of collections. First, 1, 2, 3, 4 and 5. Second, A, E, I, O and U. Third, clever students of your class. Fourth, 1 by 2, 1 by 3, 1 by 4 and 1 by 5. And fifth, rich people of your town. The collections in examples 1, 2 and 4 are sets in mathematics, whereas collections in the examples 3 and 5 are not considered as sets. Methods of writing sets. There are two methods of writing sets. First, listing method, which is also known as roster form. In this method, we describe a set by listing all its elements enclosed in the curly brackets, and the elements are separated by commas and each element is written only once. For example, A is a set of all odd natural numbers less than 10. Therefore, A is equal to 1, 3, 5, 7 and 9. B is a set of all natural numbers from 1 to 99. Therefore, B is equal to 1, 2, 3, 4 up to 99. The second is rule method, which is also known as set builder form. In this method, we describe the set by specifying the property which determines the elements of the set uniquely. For example, B is equal to 1, 2, 3, 4, 6 and 12. Set builder form. B is equal to x, where x is a natural number and a divisor of 12. Hello students. Let's learn Venn diagrams. The diagrams representing sets are called as Venn diagrams. Types of sets. Empty or null set. A set which does not contain any element is called an empty or null set. It is denoted by curly brackets or 5. Here A is equal to set of all x where x belongs to n, 2 is less than x and x is less than 3. This is a null set since there are no natural numbers between 2 and 3. B is equal to set of all x where x is an even prime number greater than 2. This is also a null set since there is no even prime number greater than 2. Singleton set. Here B is equal to set of all x where x belongs to I. X is neither positive nor negative. Therefore, B is equal to 0, which is a singleton set. Finite set. Here, C is equal to set of all x where x belongs to I, 100 by 100. Infinite set. Here, x is equal to 101, 102, 103 and so on. Hello students. Let's learn subset, proper subset and supersubset. Subset. If every element of set P is an element of set Q, then P is said to be the subset of Q and we write it as P is a subset of Q. In general, if the set X is a subset of the set Y, then it is denoted by and is read as X is a subset of Y. And if the set X is not the subset of set Y, it is denoted by and is read as X is not a subset of Y. Note: every set is a subset of itself. That is, A is a subset of A. And empty set is a subset of every set. That is, empty set is a subset of A for every set A. proper subset and super subset. If P is a subset of Q and the set Q contains at least one element which is not in the set P, then the set P is the proper subset of set Q. It is denoted as P is a subset of Q. In this case, the set Q is said to be the super subset of the set P and is denoted as Q is a super subset of P. Universal set. A suitably chosen non-empty set of which all the sets under consideration are the subset of that set is called a universal set. Universal set is usually denoted by capital U. For example, set A contains 1, 2, 5 and 6 and set B contains 1, 2, 3 and 4. Then universal set should be represented as box having all the elements and would be represented as U is equal to 1, 2, 3, 4, 5 and 6. Universal set is usually denoted by U and in Venn diagrams generally it is represented by a rectangle. Hello students, let us start with operation on sets now. Operations on sets. First, equality of sets. Let us consider set A with element 1, 2, 3 and 4 and set B with elements 1, 2, 3 and 4. Thus, A is equal to B. They contain same elements irrespective of the order in which the element has been placed. This explains equality of sets. Note, whenever we want to prove the sets A and B are equal, we have to prove that A is a subset of B and B is a subset of A.
Intersection of sets. The set of all common elements between the sets is called the intersection of sets. It is denoted by the symbol. Thus, A intersection B is the set of all x such that x belongs to A and x belongs to B. For example, let us consider set A with elements 3, 6, 9, 12 and 15 and set B with elements 4, 8, 12, 16 and 20. Thus, both the sets has element 12 as their common element. Thus, the set with element 12 is called the intersection of set A and B. Properties of sets. A intersection B is equal to B intersection A. This is commutative property. Here, the shaded part is A intersection B and here the shaded part is B intersection A. We can see both are equal. Second, A intersection with B intersection C is equal to A intersection B intersection with C. This is called associative property. Here, the shaded part is B intersection C and the darker part is A intersection with B intersection C. Here, the shaded part is A intersection B and the darker part A intersection B intersection with C. We can see both are equal. Third, A intersection B subset of A and thus A intersection B subset of B. Here, the shaded part is A intersection B and it resides inside the set A. Hence, A intersection B subset of A. Similarly, A intersection B subset of B. A is a subset of P, B is a subset of P. Then, A intersection B is a subset of P. Here we can see that if A and B reside inside P, the intersection would also be residing in P. Hence, if A is a subset of P, B is a subset of P, then A intersection B is a subset of P. Fifth, if A subset with B, then A intersection with B is equal to A. If B subset with A, then A intersection with B equal to B. Here we can see that if A resides inside B, the common part is nothing but A. Hence, we can say that if A is a subset of B, then A intersection B is equal to A. Sixth, A intersection with null set is equal to null set, and A intersection A equal to A. Disjoint set. If both the sets A and B have no common element, then we can say that sets A and B are disjoint sets. For example, set A with element 1, 3 and 5, set B with element 2, 4 and 6. Thus, both sets don't have any common element. That is, A intersection B equal to null set. Hence, A and B are disjoint sets.
Union of sets. Let A and B be two given sets, then the set of all elements which are in the set A or in the set B is called the union of two sets and is denoted by and is read as A union B. A union B equal to all element of X such that X belongs to A and X belongs to B. For example, set A with element 1, 2 and 3. Set B with element 3, 4 and 5. Thus, A union B is equal to 1, 2, 3, 4 and 5, all elements of set A and B. Properties of union sets. First, A union B equal to B union A. This is commutative property. Second, A union with B union C equal to A union B union with C. This is associative property. A subset with A union B and B subset with A union B. Fourth, if A subset B, then A union B equal to B. If B subset A, then A union B equal to A. Fifth, A union with null set is equal to A. Sixth, A union with A equal to A. Distributive property of union and intersection set. First, A union with B intersection C is equal to A union B intersection with A union C. Second, A intersection with B union C is equal to A intersection B union with A intersection C.
Complement of a set. Let A be the subset and U be the universal set. The set of all elements in U which are not in A is called the complement of A. It is denoted as A dash or A raised to C. A complement is equal to all elements of X where X belongs to universal set and X does not belong to A. If X does not belong to A complement, then X belongs to A. Properties of complement of set. Set A with element 1, 3, 5, 7 and 9. Set B with element 2, 4, 6, 8 and 10. Thus, U contains the subsets of A and B sets called as the universal set. First, complement of A complement is equal to A. A complement contains the elements 2, 4, 6, 8 and 10. A complement of A complement contains the elements 1, 3, 5, 7 and 9. Therefore, complement of A complement is equal to A. Second, complement of universal set is equal to null set. Third, complement of null set is equal to universal set. Fourth, if A subset of B, then complement of B is subset of complement of A. Set A contains the elements 1, 3 and 5. Set B contains the elements 1, 2, 3, 4 and 5. Universal set contains all elements of A and B.
Number of elements in a set. Let A be a finite set. Then the number of elements in A is denoted as n of A. Therefore, number of elements of A union B is equal to number of elements in A plus number of elements in B minus the number of elements in A intersection B. For example, in set A, the number of elements are 3, and in set B, the number of elements are 4. Therefore, here number of elements in A intersection B is equal to 1. Here number of A union B is equal to 6. Therefore, number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection B. That comes to 6, which is 3 plus 4 minus 1. Thank you for watching.